This video is suitable for students in Senior 5 and Senior 6 who are offering chemistry as part of their subject combinations. Having looked at example 1 and example 2 in this session, I continue with example 3, and I am going to attempt this using only one approach. But we have seen that such reactions have two approaches towards outlining the reaction mechanism. So in this case, I'm going to use only one approach. So we shall have the following. I have my benzene ring. Benzene, I want to react benzene with CH3, CH3, Cl in presence of a halogen carrier, aluminium bromide. So the central metal atom within the halogen carrier is electron deficient. Moreover, it is a Lewis acid, implying that it is an electron pair acceptor. Therefore, the polarity of this bond is polar, because chlorine is more electronegative than carbon. So it can take electrons, it can attract electrons towards itself and then donates them to aluminium. Then once they are donated, this chlorine is partially negative and the carbon atom is partially positive, implying that it is electron deficient. Then we donate electrons to specifically that carbon that is electron deficient. Then what shall we form? As a result, we shall have our ring, the benzene ring, like that. This bond is still there and this one is also still there. Now, one of these two carbons, since they have the same number of hydrogens, Markovnikov says that this group will go to the carbon that has more hydrogens. But from the structures of benzene, which have been discussed earlier on, these two carbons have the same hydrogen. So this group can go up or down. So observe that the electrons are being donated to CH. So I'll have CH like that. And this CH, look at it carefully, it carries CH3 this side and also it carries CH3 that side. So it carries same things on either ends. So I'll put a bracket and put CH3 with a 2 there. Then this one will be having a plus since it is electron deficient. So we have donated to this. We also form AlBr3 Cl minus, like that. That's what we form. Then there is a silent hydrogen here. There is a silent hydrogen. So we can expose it and donate electrons to that electron deficient carbon. Now once we donate electrons, once we lose this proton, once we lose this hydrogen as a way of donating electrons to this carbon, it also becomes electron deficient because we have taken its electrons, because it contributed towards formation of this bond. So we have taken its electrons and donated them, so it is as well electron deficient. Then this negatively charged ion can donate electrons to that electron deficient hydrogen. As a result, we shall have the following. So in this case, we have our benzene with the CH3 with a 2. Then this hydrogen and the chlorine plus hydrogen chloride, then plus aluminium bromide. So our products, we have, you complete here. I'm not having enough space. So these are our two products. This is not part, yes. So we have this and hydrogen chloride as our products. Do not always forget to complete the equation. That is very important. Most learners forget to complete the equation. I've not completed it because of space constraints, but those are the two products. This one and that one. So that is example 3. Example 4, I have bromobenzene. Now, some of you are going to forget that we are studying benzene and its derivative. So this is a derivative of benzene, so long as it has a benzene ring. So reactions that are undergone by benzene can as well be undergone by derivatives of benzene, like this one, bromobenzene. So bromobenzene are reacting with the methyl chloride in presence of a Lewis acid catalyst, iron 3 chloride. So in this case, we have seen that this reaction has, the mechanism for this reaction are two. The mechanisms, there are two, which I have highlighted earlier on. So allow me only use one approach. So the approach which I'm going to use, I'm going to first react my CH3. Okay, for simplicity, you can use any. Allow me use this one. So we have bromobenzene. I want to react it with CH3 Cl in presence of iron 3 chloride. For reasons that I've highlighted earlier on, this iron is electron deficient. So chlorine can take electrons, since it is more electronegative than carbon, then bring those electrons and donate them to the central metal atom in iron 3 chloride. Then this has a partial negative charge, this has a partial positive charge, indicating that it is electron deficient. Then we can donate electrons to it. As a result, we shall have the following. We have, now Markov-Nikov, let me first write my structure. We have the ring, there is bromine there, that is number one. There is a bond there and a bond there. This bond has been broken. Markov-Nikov says that once you donate electrons from a double bond, from a multiple bond to something that is electron deficient, this group is going to go to the carbon that has more hydrogens. Now we have this carbon and that carbon. I want to say that this carbon here, the carbon atom here, from the structure of benzene, this carbon has more hydrogens than this. Moreover, this lacks hydrogen. It doesn't have, because it forms a bond with this carbon here, another bond there, and another one there. Those are how many? Let me count them carefully. We have, initially, this is what we had. Look at this structure. So we have this carbon, the carbon here. It bonds with that carbon, that is 1, 2, 3, 4. It bonds with the carbon there, bromine there, and the carbon here. This is 1, 2, 3, 1, 2, 3, 4. So the 4 bonds are used up. The 4 electrons are used up. However, this carbon here has 3 bonds. It has this bond to that carbon and 2 bonds to that carbon. Then the 4th bond bonds with hydrogens. Therefore, this carbon has more hydrogens. So this incoming group will come here down, but not up. Once it goes down, then that carbon up will be electron deficient. Then we expose the hydrogen here. We are going to use it. Then here we formed FeCl4 minus. So we expose this so that it donates electrons, electron deficient carbon. So we lose a proton minus hydrogen ion. Then we form this as our product. We have a bond there, and also a bond there, because it has been restored back. BrCH3, like that. Then the hydrogen ion with the complex FeCl4 minus. This donates electrons to the hydrogen ion because it is electron deficient. Then we form hydrogen chloride plus ferric chloride or iron 3 chloride. So it is formed back, implying that it did not participate directly in the reaction. It was serving a certain purpose. So I now complete. Do not always forget to complete the reaction, to complete the equation for the reaction. So we have BrCH3 plus hydrogen chloride, D plus hydrogen chloride. Having done almost 4 examples, I have done 4 examples, explained them in detail. Now I leave these questions behind for you to try out. Outline the mechanisms for those 3 reactions. I always leave some words behind. You may think that you've understood everything, but without you getting a pen and putting ink on paper, you haven't understood. So kindly try out those questions. And that is Friedel Crafts alkylation. Friedel Crafts alkylation.